Okay, so now let us get to the section 4.4, logarithmic properties now. Okay, so just let us review some property that we learned in section 4.3, like inverse property, log base b of b to x is equal to x, b raised to the power of log base b of x equal to x, right? So for example, like 2 raised to the power of log base 2 of 37, you know that the answer is 37. And of course, we are learning the three laws. So we have log base b of a plus log base b of c equal to log base b of a times c. Log base b of a minus log base b of c is log base b of b a over c. And this one is the one that, again, we use it, right? Log base b of a to the power of r is equal to r times log base b of a. So we just bring the power down. Okay, just like this. Okay, so then, and of course, we also learned in the change of base formula. Okay. So in this section right here, we are going to use these three a lot. Okay. Okay. So let's see. How do we use those? First, I would like to introduce how do we simplify to a single log. Okay, using logarithm properties then. Now, for example, if we have a difference between the two, then basically we could use the difference of logs, right? So in this case right here, we will have log base 4 of, again, we put a parenthesis, is 5 over 1 over 5, okay? Then you have to understand that to this one, this means divisions. So therefore, in this case, I will have a log base 4 of 5 divided by 1 over 5. And then, which is log base 4 of 5 times 5. So I have log base 4 of 25. Okay, just like this. Okay. And then, how about the next one? Okay, so to this one right here, we actually, again, we have 3 times log base, log natural common log of x plus 2 times common log of x squared. Okay. Now to this one, now again, remember we would like to rewrite this into a single log. Okay. Now you will see that if we have 3 or 2 or positive 2 in front of the log, we cannot combine them right away. If you look at back, do you see that the coefficient for additions or subtractions is either positive 1 or negative 1, right? Okay. So then in this case, if we have a number in front of it, what we need to do first, we have to use this one to take care of it first. So then in this case, I will have log of x to the power 3 plus log of x squared to the square. Okay. Then of course, in this case, I will have log of x to the power 3 plus log x to the power 4. Then now we could use this, the sum property, to take care of it. X to the power 3 times x to the power 4. Then I have log of x to the power 7. Okay, yeah, then this is actually is the idea. Okay, so right now let's go ahead and try to see if you could work on 3, 4, 5, and 6, right? Okay. Okay, so to number 3, now to this one right here, what I'm going to do is, now again, let me rewrite this a little bit so you could actually see what is going on. So if we have negative right here, now of course some of you actually try to use the different property, but again, to me, I'm not. Okay, so I would like to show you this way. So then I could actually rewrite this into plus log common log of b to the negative 1 power. Okay, plus log c plus log of d to the negative 1 power. Okay, so I change it everything to plus. Then if I do this, what I could do here is I could rewrite this into a times b to the negative 1 times c times b to the negative 1 power, right? Then now you will see that if I take care of it, and then I will have a times c over b times d. The reason is if we have a negative 1 power, basically we kind of like the reciprocal, right? And bring it to the denominator, just like this. Okay. So then let us analyze, okay, the result right here. Do you see that if the coefficient is +1, what happened is actually is the expression A and C is in the numerator. If you have a negative in front of the log, then in this case, the term B and D, you put it in the denominator. Okay, so you could use this right here to help you to take care of when you have subtractions of log. Okay, then now let us look at the next problem now. Okay, so to number 4, then of course we will have log base 32 of 32 over 4, and then now we could have log base, oh my bad, this is actually is 3, right? So A3 of 8, okay, and done, right? And the next one, basically we will have natural log of 4x squared times 3x to the power 3. Then in this case, I will have natural log of 12x to the 5th. Okay, then the last one, this one. So I could rewrite this into log of x squared plus log y to the 1/3 power, and then minus log of z. Then we actually, again, if we have addition and subtraction, basically we have a quotient or factor, right? Then now what we could do here is we could put x squared y to the 1/3 and then over z. That's it. Okay. Okay, now the next one is the one that will help you. Okay, so to this one right here is actually is will again will help you in the future class. Okay, like calculus and stuff. Okay, now to this one I would like to write each expressions at the sum or the difference of log function containing no exponents. So then in this case right here, if I look at this problem right here, okay, oh, maybe I should say that the idea to this one right here basically is what? It's kind of like we have this from addition and subtraction of log to a single log. Right now we go back from this, okay, back to this. This is exactly what we are going to do. Okay, so then now let's see. How do we actually do this? Now to this one thing about this is if we have a square root, then what we could do, we could actually try to take care of the square root, right? To rewrite this into the 1/2 power. And then we could change this one to -3/2 and y to the 2/2. Okay. Again, if you don't remember this, go back to the section 4.0, right? And then now we have log x to the -3/2 and then times y. Okay. Then, of course, to this one, we could have log of x to the -3/2 plus log of y. Okay. Then my answer will be -3/2 log of x plus log of y. Okay. And now try to work it out. Okay. The number 8, number 9, number 10, and number 11 then. Okay. Okay. So to this one, now first maybe I could do this. I have natural log of cube root of a minus natural log of b to the power 4 c to the 5th. Okay. Then I could have natural log of a to the 1/3 power, and then minus natural log of b to the 4th plus natural log of c to the 5th. Okay. like this. Okay, and then maybe let us rewrite this. Then I will have 1/3 natural log of A minus 4 times natural log of B. Okay, now you will see that negative, positive is negative. And we take care of the last term. Now, to me, I have a lot of students actually make the mistake here. The reason is they thought that is multiplication, it must be plus sign. Okay, they change the plus sign here. But look at this. The step 2, we have negative, positive, right? So it's become negative. Okay. And now, how about the last one? Okay. So we could have log of a squared b to the power 3 minus log of c to the 5th. Then I will have log of a squared plus log of b cubed minus log of c to the 5th. And then of course, my answer will be 2 times log of a plus 3 times log of b minus 5 times log of c. Then. Now again, to do this type of problem, you need to practice. Okay. Then let us look at the next 2 problems. It seems that it's a little bit harder. Okay. So again, to me, I would like to take care of anything inside here, right? So I will have log of x to the power 3, y to the power 4, and then now I will have this one right here. It will be x to the power of 3 over 7, y to the power of 9 over 7. Okay. Then what we could do, we could have x to the power 3 plus 3, 7, y to the power 4 plus 9, 7. And now we have 3 times 7, 21 plus 3, 24 over 7. 4 times 7, 28 plus 9 is 37. Then now we could have log of x to the 24 plus 7 plus log of y to the power of 37 over 7. Okay, then my answer is okay, so then let us look at this one then. So to this one, I have natural log of x minus natural log of square root of 1 minus x squared. And natural log of x minus natural log of 1 minus x squared to the 1/2 power. Minus 1/2 natural log of 1 minus x squared. Okay. Then now notice 1 minus x squared is equal to 1 minus x, 1 plus x, right? So we could decompose this into 1 minus x, 1 plus x. Okay. That means we are going to make it become 1/2 time natural log of 1 minus x plus natural log of 1 plus x. Then. Almost done. Natural log of x minus 1/2 natural log of 1 minus x minus 1/2. natural log of 1 plus x. Okay. That's it. Okay, now number 12 is really similar to what we just did. Okay, what we need to do is we have to rewrite this into, again, addition and subtraction of log, right? To rewrite this into a single log without any exponent first. And then after this, then we replace the natural log A equal to 4, natural log B equal to 2, and natural log C equal to 7, and then to evaluate expressions. Okay. Now, one thing about this type of problem, you have to understand that when you have natural log of A, natural log A equal to 4, it didn't mean that A equal to 4. Okay, so because again, this is natural log of A, right? Okay, anyway, now if I have this type of problem, how do we actually take care of it? Okay, so I have some students, when they see this type of problem, they write down, oh, it is natural log of A is 4, B is 2, and then C is 7, right? And then they write down is natural log of H times 7, 56. Okay, then they have this answer. Now remember, this is not correct. Okay, now the correct way to do this type of problem is this. First, we write this into natural log of A plus natural log of B plus natural log of C. Okay. Then, now we know that natural log of A is 4, natural log of B is 2, natural log of C is 7. Then your answer is equal to 13. This is a great way to do this type of problem. Okay. Okay. So now go ahead and try B and C now. Okay. Then this is natural log of A minus natural log of B times C. And it's natural log of A minus natural log of B plus natural log of C. Okay. And now we replace the number. This is 4 minus 2 minus 7. Okay. So therefore, my answer will be, this is 2, so I have -5 now, right? Okay, then now how about C? Now C is, if I have natural log of A squared times natural log of B to the power 3. Okay, now to this one, you have to be really careful about how do we take care of it. You will see that the only thing that I will be able to take care is this one. So I will have 2 times natural log of A. Again, to this one, I cannot do anything. I could not bring the 3 down, okay? So again, you could actually look it back to section 4.3, the warning, okay? Okay, then after we have this, then, okay, so we could not simplify more. Then the next step is what we plug it in. Then I have 2 times natural log of 4 is, I'm sorry, A is 4. Natural log of B is 2, right? So basically I have 8 times 2 to the third is 8. So the answer will be 64 then. Okay. Now this is actually is, you will have similar problem on your homework. Okay. So make sure that you know what to do with this one. Okay. Okay. Then now, what I would like to do is, how do we actually solve the logarithmic equation now? Okay, so last section we solved exponential equation, right? And then now, how do we actually solve an equation containing log? How do we do this? Okay. Now the idea is this. First, we would like to isolate the log term on one side of the equations. You may first need to combine the log terms. And the second, we are going to write the equation in exponential form. Okay. For example, like log base B of C equal to A, provide that B to the A equal to C, right? Remember this? How do we do this? And then, of course, the last step is we solve for the variable. So then let's look at this equation. I have log of 50x plus 25 minus log of x equal to 2. Then in this case right here, now again, I will already have a log to one side. Then what I'm going to do, I'm going to combine, okay, this into one term. So I have log of 50x plus 25 over x then because of this minus sign, right? And then remember this base right here, because it's common log, right? The base is 10. So I will have 10 squared equal to 50x plus 25 over x. Okay. And then from there, then you solve the regular equation, right? So we could multiply both sides by x, and then we group the x term together, and then we solve for x, just like this, okay? So therefore, again, the harder part is how do we actually try to see how we eliminate the log, this operator then. Okay, then now let us look at the following example then. Okay. Now to this one right here, then we actually first, we know that we would like to combine the left-hand side, right, into a single log equal to 9, okay? And then now, what we are going to do is we are going to take care of this. So now remember to this one, the base is 10. So I have 10 raised to the power of 9 equal to x plus 4 times x then. 10 to the power of 9 equal to x plus 4 times x. Okay, just like this. And of course, we will have 10 to the 9 equal to x squared plus 4x. Okay. And now, you see that we have a quadratic formula, right? Quadratic equations. Then I am going to move everything to one side of the equations. Okay. And then now, what do? We are going to solve for x. And in this case, we will use a quadratic formula now. X is equal to negative b plus or minus b squared minus 4ac over 2a. Okay. Now, on your homework or on your tests, okay, that's mean when you work on the test, if you are using quadratic formula, I would like you to actually, at least you set this up, okay? And then you could use your calculator to find the values. But again, this is really important step that you need to set it up or write it down on the paper, okay? This is actually part of the credit if you use quadratic formula. And now we have x is equal to negative 4 minus square root of 4 squared minus 4 times 1 times negative 10 to the 9 over 2, or we have x is equal to negative 4 plus, okay, maybe let me write this. So this is 16, negative, positive, 4 times 10 to the 9 over 2, okay? So if you use your calculator to plug it in, you are going to have two answers. The first one is negative 31624.77666. Or you have x is equal to 31620.77666. Okay. Now, one thing about this is when you have the solutions, most of the time when you try to solve for log, you may need to reject one of the solutions. The reason is this x right here. It must be positive. Okay, it must be. So therefore, again, you will see that when I plug it in this one, this result x to this one or to this one, it gives you negative, right? Meaning you are going to reject this solution right here. Okay. Therefore, in this case, your only solutions will be this one then. This is the only solution. So I will have the answer is x is equal to 3162.77666. So therefore, again, remember when you try to solve log, you always need to check it back to the original function, okay? Okay, so now it is your turn. Now go ahead and work on the number 14. So I have log base 3 of x squared over x plus 2 equal to 5. Then now I will have x squared over x plus 2 equal to 3 to the 5th. And then we know that 3 to the 5th is 243. And now we could have x squared 243 to x plus 2. Okay. And then now, again, we have a quadratic equations. So I will have x squared minus 243x plus or minus 486 equal to 0. Okay. And now we are going to write the quadratic formula. So I have x is equal to negative of 243 plus or minus square root of negative 243 square minus 4ac over 2, right? Then now, if you use your calculator, you will find out that x is equal to negative 1.9838 or x is equal to 244.9838. Okay. Now to this one, do I need to reject any solutions though? Then let's check. So to this one, I have x squared here, meaning I don't need to reject these solutions because this is positive, and then this is also positive. And then how about this one? I have negative 1.9838 plus 2. Again, the result that I get is still positive. So in this case, I will keep both solutions then. Okay. Now the next two example, number 15 and 16, is a slightly different than the previous one. So to this one right here, you have to understand one technique. Now this technique right here is, if I have natural log of x equal to natural log of y, so what does this mean? It means that x must be equal to y then, right? So I'm going to use this idea right here to take care of number 15 and 16 then. So in this case, again, to this one, I have common log of x plus 15. It will be common log of 15x. Okay. Then now, what we could do again, okay, kind of like by comparison, right? So meaning x plus 15 must be equal to 15x then. Okay. So then in this case, I will have 15 is 15x minus x. And of course, x must be 15 over 14. Okay, so now it's your turn to do number 16 now. Okay, so I combine the log, and then now I have x times x plus 6 is equal to 6x now. Okay. Then I will have x squared plus 6x minus 6x is, oh, my bad, this is minus sign. Ooh. Right, equal to 0. Then now I have x squared minus 12x equal to 0. And of course, I could factor the x. So I have x is equal to 0. or x minus 12 equal to 0, where x is equal to 12. And again, we know that we are going to reject this one because I cannot have this equal to 0, right? So then my only solutions is x is equal to 12. Okay, so then now this is actually the technique that you need to learn how do we actually solve an equation related to log, okay, or common log, right? Okay, so and also in this section right here, this is really important that you know how to work with the sum, the difference, and the exponential properties of log. Okay, thank you.